Welcome everyone. In this video lecture, we will study about law of conservation of momentum. It's a very important law. This will help you to solve multiple problems in your physics law of motions chapter. You might have heard a lot of problems around collision and all that. This will help you solve all those problems pretty easily. In terms of definition, what it is telling us is, in absence of external unbalanced force, this is important. If there is no external imbalanced force present, then sum of momentum, which is pool of one, sum of momenta of two objects before collision is equal to sum of momenta of those objects after collision. Let's consider an example here to understand this definition more. Let's consider I have an object 1 moving forward with some velocity and object 2 moving backward some velocity. Okay, now so they will collide somewhere here. What this definition is telling me, that initial momenta of both the objects, which is p1 plus p2, is equal to the final momenta of two objects. Let's say those final momenta is p-1 plus p-2. Okay, so as long as I know what is the momentum before, I know what is the momentum of the system after. So when I say system, so I consider these two objects as my system. Now collision doesn't have to be between the two objects. There could be more than two objects. Let's say number 3 object is colliding from here, number 4 here, number 5, number 6, and like so many balls. Okay, so I can say sum of pi, let's say I goes to 1, 2, and there are n number of objects, is equal to sum of p dash I, which is p dash is after the collision, right? So initial sum of momentum is equal to the final sum of momentum. And remember, momentum is a vector quantity, so don't forget to provide your direction. Okay, so let's look at one example here. We know about the collision between the cars, right? So this car, let's say, is moving with momentum. Let me use a little bit darker. Is p1, right, in the right direction, and this car is moving with p2 in the north direction. Okay, so this is in east, this is in the north. Remember, the direction is important because momentum is a vector quantity. So what this definition is telling me is that p1 in the east plus p2 in the north. So this is before, right? After would be p1 dash and whatever the direction, right? p2 dash, whatever is the direction. So sum of momentum in the beginning is equal to sum of momentum after the collision. If there is no unbalanced force, if I add some kind of force in the system, this equation is not valid anymore. Okay, so whenever this force is unbalanced force is equal to 0, this equation is okay. Okay, let's look at one more example here. Let's say this ball is initially at velocity 0, so v is 0, and this ball is moving in this direction with velocity v equal to 1 meter per second. Okay, now the mass of this object is 10 kilogram and this is 1 kilogram, and I'm telling that this is a positive direction, this is a negative direction. Okay, so initial momentum is what? This initial momentum of this object is 0 because velocity is 0. Initial momentum of this object is what? 1 kilogram into velocity, which is minus 1 meter per second. Velocity is in the negative direction, right? And so let's say after their collision, when the collision happens, this object moves with some velocity v1, and this one moves with some velocity v2. Okay, so after the collision, and then so this would be minus 10 kg v1, right? And this would be 1 because v2 in positive direction, 1 v2. Okay, so I can easily write that v2 minus 10 v1 is equal to minus 1. Even though I don't know the v2 and v1 at this point, this relation is true because of the law of conservation of momentum. Initially this object was at velocity 0, but it will have some velocity after the collision. So just remember these things, that law of conservation of momentum is telling me the sum of initial momentum is equal to sum of final momentum.